Now here we developed the formula for finding out the distance between any two parallel lines. Now that is very much on the similar lines of the previous result that we saw for getting a distance of a point from the line. So look here, the two lines are shown in yellow, they are parallel to each other, and being parallel we can definitely take their x and y coefficients to be exactly same, but it's only the constant terms that are different. So that we already know that the parallel lines will have the constant terms differing in their equations. So we take them as C1 and C2 as shown. Now let's consider any general point, say x1, y1, that lies on one of the lines. So let it lie on the second line as shown here. So it means that it will definitely satisfy the equation of that second line. So we have with us the condition that ax1 plus by1 plus c2 equal to 0, right? So this we label it as relation 1. Now we can find out the expression for distance of a point from the second line now, that is ax plus by plus c1 equal to 0, and we have already developed the formula for that, right? So therefore that distance d is given by, the way to remember it is like we write the expression for the line by putting the coordinates of the required point into x and y. So therefore here we get a x1 plus b y1 plus c1 divided by root of a square plus b square, correct? Now that is equal to, if you observe, this ax1 plus by1 can be replaced from the first equation by minus c2. So we can replace it as minus c2 plus c1 as it is upon root of a square plus b square. So therefore finally we can write d as, just to rewrite it in a way which is easy to remember, that is mod of c1 minus c2 upon root of a square plus b square. That's it. That's the formula for getting the distance between parallel lines. And since the lines are parallel, that particular distance will be same throughout along any perpendicular segment joining the two lines. Just to highlight one important point, that is, while finding the distance between two parallel lines, the coefficients of x and y must be made exactly same, right? If they are not, then we have to first make them same, and only then we get the correct values of c1 and c2 to be substituted in the formula. So let us see how to use this formula in the sum. Find the distance between parallel lines 3x plus 2y plus 6 equal to 0 and 9x plus 6y minus 7 equal to 0. Now first of all we see that apparently the equations look different, but if you look closely at the x and y coefficients, you see here it is 3 and 2 and here it is 9 and 6. So clearly they are in the ratio, that is 3 multiplied by 3 is 9 and 2 multiplied by 3 is 6. So clearly since x and y coefficients are in the same ratio, that means the lines are parallel. But as we have just seen, we have to first make the coefficients of x and y exactly same. So therefore let us multiply the first equation by 3, therefore we will get 9x plus 6y plus 18 equal to 0. Right? Now these two equations become in the exactly required format, where a is 9, b is 6, correct? c1, that is a constant in the first equation, that is minus 7, and c2 is constant in the second equation, that is 18. Now therefore the distance between two parallel lines, let us rewrite the formula first, that is c1 minus c2 upon root of a square minus b square. Now just one thing to observe, as we have a modulus sign here being a distance, it does not matter in what way we write the subtraction in the numerator. So that is whether it is c1 minus c2 or c2 minus c1, it won't make a difference. Right? So let us continue. c1 is minus 7 minus 18 whole divided by, sorry, denominator should have been a square plus b square, that is 9 square plus 6 square, so which in turn is equal to minus 25 divided by 9 square is 81 and 6 square is 36. So therefore that turns out to be 25 divided by root of 117. So that is the final answer. That's the distance between two parallel lines.